it's a player on it, and is the index of this tile the same as the current pawn's index? This means that we have clicked the current pawn. So if we click the current pawn, what do we do then? Well, the way I've designed it is that if the current move of our current pawn is greater than 0, then we want to set its current move to 0 and activate it. This means that it stays where it is, and then it checks for tiles in range. So just to show that. See. Yeah, so we click ourselves and we find the tiles in range. So there you see it in action. Now if the current move is not greater than 0, that means we have already moved probably, then we just end our turn. So you can also see that here. See. So we click ourselves first thing, and now we have no movement, and when we click ourselves we end our turn. So I've designed this to be, without any sort of buttons for ending unit turn and stuff like that, which are often in these kinds of games, to make it as like simple and stripped down as possible. But so that's sort of an intuitive way to do that, I think. But it's easy enough to add other interface buttons instead. So, but yeah, if this is false, that means we have clicked an index which has a player on it, but it's not the current pawn, so we've clicked a different pawn. So can the player switch pawns, which is set in the grid manager? If it can't, then we don't bother doing anything. You can click that pawn all you want, nothing's going to happen. But if we can switch pawns, then we check. So the pawn that we are clicking, the click tile finding the pawn actor array, getting that pawn in particular, we get his has he acted this turn variable. So if he has acted this turn, then we don't want to be able to switch to this guy because he has already acted. If he has not, then we want to be able to switch to him. And then we find our own pawn has our own pawn acted this turn. So if he has acted already, so we have, let's say we have moved a bit, or we have moved but we haven't attacked yet, and then we switch, we don't want to be able to switch back to him. And that's how I made it in any case. Though if we have not done anything yet with him, we want to be able to switch back to him later. So we get a few different things happening depending on that. So if he has acted this turn already, we want to let the first pawn in initiative become the last. So the current pawn, we move him to the back. I've talked about this function before in the game mode. So we run that, which is from the game mode. And then we set the current move of the current pawn to be equal to his max move. So that next time is selected, he can move his max move again. But if it is not acted this turn, like I said, then we instead just set the unit that we have clicked to be the first in initiative. So the unit we have clicked is moved to the top, and the pawn that was, or the unit that was the current unit, is now the next in line. So after he is done, we will go straight back to the previous pawn we had selected. Then again we clear all the in-range mesh markers. We set the current pawn to the new pawn that we found on our click tile, and we activate that unit. So this thing actually bypasses all of the game mode stuff and does it on its own. I've considered moving this over to the game mode instead, since it perhaps makes a bit more sense there, but I've kept it here for now. And then we set is panning to false. This is also similar to what we do in the game mode. Yeah, so that's all of the different things that can happen when you click a tile. So there's one more thing left in the player controller, and that's the display path on hover. So when we hover over a tile, we want to display the path to that tile, right? And there's a couple of other things here as well. That every tick, when we hover, we set the marker location of the current pawn to be equal, or the marker location of the current pawn marker to be equal to the location of the current pawn. So that's, let's see. easier to visualize if I show how it works. That's this mesh here. So that's always on the current pawn. So it stays with us, and when we change to a different pawn, you can see now it's around this guy instead. So this is, uses the set marker location function to do that. And then after we've done that, we get the tile location and index, the index under our mouse. I've also talked about this function before, and we set the index to be we check first to see, are we hitting the path trace? Is this a tile that can be moved to? So if it is not, all we want to do is delete the old path, but not display a new one because we can't move to that path. But if we did hit, then we check, is the tile we hit different from the last tile we were hovering over. If it is not, we don't want to generate a path again, then we generate a path every tick, which is completely unnecessary. So we only want to generate a new path if we are hovering over a new tile that is different from the one we hovered over. But if it is different, then we set that to the new current tile hover, and then we set the marker location of the hover marker to be equal to the location of current tile hover using this function. And if it's the player turn, we also want to display a spline, or a path in the case. So we check if the current pawn is idle, so if we're moving or attacking, we don't want to show these sorts of splines. But if we are idle, then we check the tile we are hovering over. Is it empty? Is it a player? Is it an enemy? If it's empty, then we want to display a path, right? But first we check, is the can move to array, is the cost higher than 0, just like we did before. So if it is, or greater than 1 actually, let's see, does this work again? Yeah, greater than 0. And we find a path within the pathfinding array, the function I described earlier, and create a path spline display path, and so on. So if it's not greater than 0, that means we can't move to it, we just want to destroy it, the old path. By the way, here you can see just the two different destroy functions, depending on we're displaying it as a spline or not. So that's if it's empty. Now if it's a player instead, so if we're hovering over another player, we don't want to display a spline at all, so we just destroy it. If it's an enemy, then we check, is the range array larger than 1? I mean, if it's standing right next to, so this is whether or not we want to display like the straight line that we show when we're aiming over an enemy. So is it greater than 1? If it is 1, then we're adjacent to them, so it doesn't look good with it, just a tiny little spline like that. But if it's greater than 1, then we want to show that line. So in that case, we display a straight spline between points. If not, then we find, so if he's not within the range array, so we can't attack him from where we're standing, but we can move to him, then we want to display a path to that pawn instead, unless he's standing straight next to us. Yeah, so but if he is within range but outside range of 1, then we display a straight spline between these points. So we destroy the spline path again, and we find a ranged attack path. So yeah, we clear a couple of or the path vector array here, and then we just have two different points in the path vector array. We have the target, and we have the attacker, the index of each and the height of each. So we create two different points in our path vector array, and set the spline world points of the path spline to be these two locations. And then we simply display that path as a spline. Yeah, okay, so that's the entire player controller. So yeah, let's move on to the next one, shall we? I guess a lot of YouTubers split up their videos, and I guess there are some good reasons for that, but yeah, screw tradition, we just keep going on until I faint. So, what's next? Let's see. I guess the AI controller is up. It's kind of similar to the player controllers in a few ways, so should go fairly quickly, I hope. So here's the AI controller. So yeah, we also have an event begin play on this one that sets up a few references. I mean, like the grid manager reference and the game mode reference, just for ease of access. So when we activate the AI unit, you can see that this is pretty similar to when we activate a player unit. Even though we don't display the tiles, we continue searching beyond its move range, and we stop searching if a target has been found. So the inputs are a bit different. And when finding tiles in range, we also don't display them. We only find pawns to make it quicker. There's no point in finding every possible tile for if we don't want to display them. So we only find whatever is relevant to find. So that's pretty much the same. But then we append the reachable pawns array. If you remember, this is generated in the pathfinding array, all the pawns that we can reach, and the pawns in sight array, which is all the pawns we found that were visible with the find tiles in range. So we append both of these into the reachable pawns array. So now we know all our possible targets, all the possible players that we can attack. So let's check now. So now we check this new array. Is it larger than 0? So are there, when we searched our entire movement range and we kept going like for ages, and we tried to search visually and we still didn't find anything, then we just choose the next pawn. We don't bother. But if it's true, so if there is someone we can attack either in sight or in movement range, then we get all these reachable pawns, and we try to find the best one. We make a choice array between all of these possible pawns. Again, this shouldn't be connected. This won't work in 4.8. So we clear the old choice array, and then we get all the pawns in the pawn index array, and for each of them we add their current health to the choice array. This is how the AI decides who to attack now. It attacks whoever has the lowest health, really. So first it adds the health of all these pawns to the choice array. So that's easy enough. Let's see. So after doing that, then it finds the pawn with the lowest health in the choice array. And it does this by getting the choice array and finding the minimum of that float array, so that whoever has the lowest health float. And then it finds that index, and that index will correspond to the index in the reachable pawns array, since we use the reachable pawns array to generate the choice array. So then we have the index of the pawn we want to move to, and we get and we find that particular pawn, and we get that pawn's index, and we output that here. So with that output in mind, then we check. Then we check inside the pawns in sight array to find, is this pawn that has the lowest health, is it within the pawns in sight array? And if it's let's see, so if it's -1, that means it returns false. We have not found it. So this way we decide, is the best target pawn in attack range, or do we have to move to him? So if it is within attack range, then we want to just attack him straight away. We just stand where we are and we attack them. So then we get the pawn with the lowest health from the choice array, same guy as we found here. We set that to the target index. So this is our target. And then we simply run the attack victim function on the current pawn. And which victim do we attack? Well, we attack the target, which is on this index here. Now, if the target is not in sight, so we have to move to him, then we also set the target index to this. This could be set beforehand actually, and would save some room. Yeah, I should do that later. But yeah, then we find the path from the index from the target we want to move to, and we find the path to the current pawn, which is outputted in the path index array. And then is this target outside the pawn's move range? So we do that by checking the current move of our current pawn, and if that movement is lower than the length of the path index array, the length of the path we have found, then we just have to move to the closest one. So let's see. So let's first see. No, it's not outside. It is within range. So if it is, then the target is pawn, which you may remember from the player. And is it more than one tile away? So if it's not more than one tile away, then we don't bother moving and we just attack him, because we're standing right next to him. Then we assume that we can attack him. But if it's true, the target is more than one tile away, then we set the marker location, the target marker, and to the location of our target. We set visibility of the target marker. We find the path within the pathfinding array within the two tiles, just like before. In the player controller, we set has acted this turn to this current pawn to true, like in the player controller, and we set the array elements of the pawn array of the index we are leaving to empty, just like in the player controller as well. And the same thing with the pawn actor array. We remove the current pawn from the pawn actor array. And then we begin its movement, which is called inside unit parent. And then we set the current move of our current pawn to subtract the movement cost of the movement it just started doing. And then we clear the can move to array, just to be sure. So that was quickly explained. I hope you could you could follow. If you haven't seen the player controller part, you should probably see that, since I explained stuff more detail there. So yeah, but if it is outside the move range, so we have to just move to the closest one. So then we check if the current move of the current pawn is greater than 0. So if we have a movement of 0 for the current pawn, then we just choose the next pawn because it can't move. But if it's greater than 0, then we find the reachable index closest to the target. And now I can explain this actually, which is in the grid manager. We do this by checking the path index array, the array holding all the indexes of our path. And for each of them, we check. We check the cost of that array element, and we keep going until we find one element that has a cost that is equal to or lower to the current move of the current pawn. That means that we can move to that index, and then we have found the index, the tile that we are able to reach. So that we set that as the target. The target is not a pawn, and then we set the marker and so on, and we move. So that's the AI controller. Quick and easy. So that means, ladies and gentlemen, that we are done with all our big gameplay blueprints. Actually, we have a few more here, but they are pretty simple. We have the HUD blueprint, which is very, very simple. It only has this little player turn text here, which is, let's see, I worked so little with UI, which is a variable, so it can be modified in the graph, and it only has this simple event. So here first we get a reference to the tile spawner. I even had a little error here, but I should add more of those. But yeah, and then when we run the event HUD turn toggle, which is fired in the game mode when a new pawn is selected, and we have found out the faction. So it has player turn as an output. If it's the player turn, then we set the text block to say player turn. If it's not, then we set it to say enemy turn. So this is Very, very simple. And then we have the grid camera, of course. I need to update this because some of this stuff actually doesn't make that much sense. I'm using the delta seconds all wrong. Many of the places I'm using them, but yeah, it works. Anyway, so these are pretty simple things, really. That when you click the rotate input axis, then you set the rotation of the camera actor. When you zoom, when you scroll, then you set the length of the of the spring arm. You can see here that there's a spring arm above the actor itself, and on top of that spring arm is a camera that's looking down. So when we zoom, the length of this spring arm is shortened or becomes longer. So that's what happens here in the zoom. And in panning, we simply we set the location of the grid camera. And then there's the follow cam. So if enable follow cam is set to true, and then we get the current pawn in the game mode, and we are not currently panning the camera, then we want to follow the current pawn. So in that case, we set the actor location of this camera to be equal to the location of the current pawn, though we lerp towards that location, so it's a smooth, or rather smooth movement, though I should change these alphas. But yeah, that's the grid camera. Okay, and the grid manager hex is just the grid manager with a few things set up so that you automatically have a hex grid, but it's the same really, just a child actor. So that's that. Then let's look at the unit parent. So unit parent is the base unit, which all other units are based on. It works in and on itself just like this, or it should work. Let's see. So I set it up so that you don't need to have any animations or anything like that, so you can just change this, you know, with like a spaceship mesh or anything. You don't have to bother with animations, so it still works, it still attacks, still takes damage, all that other stuff. And then all the animation stuff is added on these child actors. But yeah, so unit parents, let's see, so this one both has a construction script and an event graph. So in the construction script, a lot of stuff happens here when you drag the pawn into the viewport. So firstly, we set up the health bar. We created dynamic material instance, the health bar, and set a dynamic health bar material. This is so that it is possible to change the values of the material of the health bar, because the health bar is a pretty simple material. Let's see if I can find it here. Where's the health bar? There. Yeah, which has a percentage fill between two values of black and red, depending on yeah, it depends on this percent fill variable. So we change this variable, and then the material changes to reflect the current health of the unit. So we have to set up a dynamic health bar material so we can change that. And we always set the dynamic health bar material, or this scalar parameter value, the percentage fill value, to be equal to the current health of the pawn divided by the maximum health of the current pawn. Yeah. So let's see, so we get the grid manager. So yeah, didn't bother to make a reference here, though I use it quite a bit. Though we used the grid manager for quite a few things. We used this vector to index interface, which is a very simple interface inside the grid manager. Let's see, you can see it when it's here. Actually, I have to go to the grid manager, it seems. Where's the interface? There. I want to sort these alphabetically soon, which simply takes a vector and gets it through the vector to index. You remember this old macro, and outputs it. You should probably just put it within a function, so it didn't need that. But yeah. So it gets the location of the actor, and then it puts it into this function, or this macro, and then it outputs the index. So that way we always know when we move one of these. Let's choose one that's visible. When we move a tile around, or pawn around, if you see here on index, it changes as we move, and that's how that happens. Yeah. So, and then we check, do we want to snap to the custom grid that we have? If we don't, we can just stop there. We don't want to do anything more, actually. If we want to, we check if this particular pawn ignores snap to custom grid, because that can be disabled here. So currently you can see, oh yeah, it's not, yeah. So now he's snapping, right? Snap, snap, snap. And now he's not. So that's set up here. But yeah, so if we're not ignoring snapping to custom grid and snap to custom grid is true, then we wanted him to snap to the custom grid. So we get the index, which we got here, and we send through this get vector array interface, which takes the index, gets it through the old vector field array, and outputs that location. So that's the location of that particular index, which will always be in the center of that particular tile, and also adds the location of the grid manager. And then we break that vector. This is just and do a line trace. So we do that to check if the tile that we're moving the pawn to has a different height. And in that case, we want to set the pawn at that particular height instead of like at the Z of 0. So yeah, and then we set the location of the custom grid anchor to be equal to the location we now found. And the custom grid anchor is, let's see, is the one that's here. That's an anchor that's always placed in the center, and then anything that's attached to the custom grid anchor will be which in this case the skeletal mesh is and the health bar is, will be moved to the center of the tile. Right. Okay. And do we want to place the actor at the anchor? Yeah, this is so that we can now, you see, you can move the actor back to where the anchor is. If we want to do that, then we set the actor location of the custom grid anchor. We set the actor location of the actor of the self, the unit, to the location of the custom grid anchor, and then we set place actor to at anchor to false. So we don't loop that forever. That's in the construction script. Then for the event graph, we have a lot of things. So first we set up our references like we've done many times before. This time for the game mode and the AI controller. And let's see, for every tick we want to rotate the health bar to face the camera, so that is always facing us. So that's a simple set world rotation where we get the location of the camera manager and find the look at rotation between that and the health bar. So that's simple enough. Then here we have movement, which is done every tick, but we have a gate here. So it's opened if we want to begin our movement. If not, it's you enter but it's closed, so nothing happens. Now when we begin movement, which if you can remember is fired from player controller and AI controller respectively, and it also gets these inputs: stop X tiles from target and attack on end, which is set in the player and AI controllers. So we have those stored here. So attack on end is true if we have clicked an enemy that we can move to, or if the AI can move to and attack an enemy. And stop X tiles from target is also set if we click an enemy, because we want to stop one tile in front. So yeah, so if it is open, we want to move, and then first we do one thing that we only do once, though we reset it when we end movement. And what we want to do once is to get the spline length of the path spline, and we set that to the current spline distance. So the current spline distance, that's where on the spline is the pawn currently located. And the length, that is, since the spline starts at the target and ends at the start position, that means the start position is at the location of the length, the entire length of the spline. So that's where we want to start. And we set the unit path spline, so that this is a particular spline that is contained within the unit is set to be the same as the path spline in the grid manager. So after we've done that, then we do that the thing we want to do every tick. So we set idle to false. We don't need to do that every tick, actually. I should move that up here. Yeah, but yeah, it doesn't really matter. So is the pawn, but I will change it. Is the pawn target outside its move range? So we check that to check the length of the path index array compared to the current move. So yeah. Let's see. Actually, that might not be necessary anymore. I'll have to look into that as well. But yeah, so I think this should always fire false now. I might be wrong. But in any case, we stop movement if it has reached the end of the spline, or the node before the end if the target is a pawn. So we get the path spline, and we check the distance along the spline to that particular spline point, and usually this will be equal to 0, which is the target. So if we get point index 0 and we find where is that on the spline, which is actually on spline distance 0. If it is true, then we want to stop the pawn. If it is not true, that means we have not reached our end target yet, and we want to accelerate and move the pawn along the spline. And so we want to keep accelerating movement speed until the max speed is reached. So we accelerate the movement of the pawn, so there's a smooth movement when we start moving. So we check if the max speed of this pawn is it greater than its current speed. If it is, then we want to keep accelerating, right? So if it is greater, then we want to add the acceleration every tick to its current speed until we reach its max speed. If it is already at its max speed, we just want to keep moving at that speed. And then we set the current spline distance, like the position the pawn is currently on the spline. We want to increase that. And we increase it by getting the current speed and multiplying it by delta seconds, and multiplying that by the tile bounds of the grid manager. So yeah, the speed of the pawn is dependent on the size of the grid. So this is so you can resize the grid and use the tiles you want, and the movement across tiles will stay pretty much the same. But yeah, and then we subtract that from the current spline distance. Remember, we started at the length of the spline, the absolute max point of the spline, so we subtract that value, the current speed value, until we reach the end. And then when we change the current spline distance, we want to set the actor location and rotation of our pawn to be equal to the current spline distance, location and distance along that spline. Yep. Let's see. Where are we? There we are, and there. Okay. So when we have reached our destination and we want to stop, and then we set the current speed to 0, and we set the actor location to be equal to, let's see, the index of our end point, which could be 0, or if we want to stop X tiles from the target, it will be a different number than 0. But we should be stopping there anyway, and but just to be sure, we make sure that the pawn is at the exact location we want it to be. And then we set the index of our pawn to the index where we ended up staying. And then we set the array element of the pawn actor array to the faction of our current pawn at the new index. So we add its faction to the new index. And we also add the pawn itself to the pawn actor array at that index. So now the arrays are updated so that we know that the pawn in question is on the new location. And then we fire the end movement custom event, which is here. Earlier here we would just close that gate, which stops the tick from firing the movement event. And after that, are we attacking on end? If we are, then we attack the victim on the end of our path index array. If not, then we set the visibility of the target marker. We make it invisible because we have reached our destination. And if it's, let's see, if it's the player turn, after we have moved, we want to activate that player again. And if it's the AI, we want to activate that AI again to see if they can still do anything more. As you saw in the player controller and AI controller, if they can't do anything more, then the next pawn is chosen inside those blueprints. So yeah, so attack victim, let's look at that. So if we're attacking someone, that's here, straight beneath in the same event graph. So we attack the victim. The input of the victim was whatever pawn was standing at the end of our path index array. So we attack this guy. First we set the marker location of the target marker to the same location of the victim we are attacking. And we set the visibility to true. And then we set the rotation also of our actor to be facing the target he is attacking. So we get the look at rotation between the actor and the target he is attacking, and set it as his new yaw. And then on our victim, we set him to receive damage. So we get the damage of our current pawn, and also the animation damage delay. This is how long from the attack starts until damage is dealt, which should be set depending on how your attack animation looks. So we do the receive damage event. So this is fired actually on the target, even though it's in the same event graph. This will be fired on the target. So here we delay for a duration, which can be set custom depending on your animations, and then we set the current health of the victim to be equal to its old current health minus whatever damage was dealt. And then we set the scalar parameter value of its health bar to be equal to now its new current health divided by its max health at the percent fill value. And we set the marker visibility of the target marker to be false. After we have attacked, we don't want to see the target marker around the victim anymore. And then we choose the next pawn. I think this should maybe be moved to somewhere else so that you can do stuff like area attacks and do damage without ending your turn. I'll change that in a later update, I think. So you'll probably see a little annotation up here soon. Okay, and then if the current health of the attack of the victim is lower or equal to 0, that means we want to kill it. So if it is, then we set the visibility of its health bar to false. So the health bar disappears. Then we set the array element of the pawn array at its index to empty because there's no pawn there anymore. And we also remove it from the initiative order. And we remove it from the pawn actor array. And then we call destroy unit, which also has a death anim delay. So the animation of death starts at once, but this is how long we wait until we destroy the unit. So if you always want to have the corpse laying there, you can set this to infinite, I guess, but yeah, it would be better to change that up, I think. Okay, and destroying the unit is simple. We have a delay, and then after that we destroy the actor. So that's all of that. But now let's look at the animation bit. Let's see. So for animation, let's look at pawns, and then we'll look at any one of these. So let's look at unit pair melee. So it does only a few things. So it runs the tick event, which is on unit parent, and it runs the attack victim. It runs all of the functionality that is within unit parent, but it has some additional stuff as well. So on the tick, it also runs some more stuff. If it is idle, Let's see. So the moment it has become idle, then we want to stop its move animation. If it's not idle, then we want to move to play the move animation. Let's see. So then we get the animation instance of its skeletal mesh. We cast it to the animation blueprint parent, and we run its move animation. So that's inside the animation blueprint. Yeah. Let's see. And as for attacking, we want to also cast to its animation blueprint and run the attack animation. When it's dying, we want to cast to the animation blueprint and run the death animation. So that's basically all there is to that. But yeah, so this interfaces, of course, with the animation blueprint parent, though there are different animation blueprints for different animations. So for the move animation, we cast to unit parent to find its current speed, and then we set the speed value of this animation blueprint to whatever is the current speed of the unit parent that has this animation blueprint within it. So if the speed is 0, we want it to stand idle like this, right? But if it's higher, we want it to walk or run or whatever. And if we run the attack animation event, then we set attack to true, death animation set death to true. So these will check branches that will fire either of those animations. And then we have an animation notify at the end of the attack animation that stops the attack later. So we have that in the state machine here. So in the state machine we have the idle walk run, so we get the speed value that we just set, and we run it into this blend space. I mean, I have described this before in the animation part, so maybe I won't describe it too much here. But yeah, that's and the speed value between 0 and 600 decides which animation is played. And yeah, then we check this: is death set to true, is attack set to true, then we want to run the punch or the death animations. And after punch has run, let's see, so we have the attack, then we check for this notify event here. So when that is run, it checks this, so it goes back to the idle walk run part of the blueprint. So that's very quickly, but I've already described this in a previous video, so I won't go into that anymore. That's that for animations. Okay, we're actually getting pretty close to the end, I think. Though we have one more thing: the tile parent. So the base of all tiles also has a lot of its own stuff, though a lot of it is the same as in the unit parent. So it has some other stuff as well. So also here it finds the index on the grid, just like in unit parent, and it checks if it should snap to the grid, and all of the same stuff, actually, finding the height, setting its location, should it be placed at the anchor. All of this is identical to unit parent, but it also has this stuff. But yeah, I think I won't go into this since it's pretty complicated. The whole functionality that makes all the static meshes turn into instant static meshes. Because let's have a quick look. You can hear my skepticism, I'm sure. Yeah, this is to replace actor meshes with instances, and there's a lot of custom small. Yeah, I can make another video of this if people are particularly interested, but I actually kind of hope not. But yeah, it was fun to make though, but it's kind of tricky to explain. But it has some pretty huge performance gains, for some stages at least. Okay, let's see, do I have anything more? I got the HUD, I got all of these. I think we're actually there. Yeah, so that's that. I'm sure that there's a lot of stuff that I could have explained better. Some stuff I explained for too long. But yeah, I've done my best in any case. Try to keep it like reasonably deep, but not too much of a good thing, I guess. But just ask anything that's confusing in the comments below or in the forum thread, and I will answer as quickly as I can, and I will try to clear up future confusions or any of those confusions in annotations in this video that we'll add in the future. And when I update this toolkit, as I do quite regularly, then I will add annotations to note where there have been done some any changes. But I hope that things are in a finished state enough that I can keep this video and just add comments like that. So I hope you enjoyed this video, and if you managed to watch it from start to finish, I commend you, and I hope you I wish you luck in your project, and hope this will be useful in letting you make whatever turn-based strategy games you want, because I want to see lots of new cool turn-based strategy games come out of Unreal Engine in the future, and that's why I made this stuff. So well, yeah, that's it for now. Bye bye.